Hi Jacob, my name is Alex and I'm gonna do an optimization problem. So, our problem says we need to enclose a rectangle field with a fence. We have 500 feet of fencing material and a building is in one side, so the fence doesn't need to be there. Determine the dimensions of the field that will enclose the largest area. So, I'm gonna draw it so it's very clear. We have an area. And here there is a building. Okay, so we need to fence the terrain, the area, and get, well, the measurements. But this side doesn't need to be fenced because here is a building. So what we need to do at first in any optimization problems is set up our two functions. So they said that the area needs to be a maximum. So we know that the area of a rectangle is base times height. So we're gonna set up some variables so it's easier for us. We're gonna call this side x and we're gonna call this side y. As I said earlier, the area is x times y. And they said that we have 500 meters or feet or whatever, kilometers if you want, of fence, and we need to set up in this perimeter, so it's a maximum. And the perimeter of this side is 2y plus x, not 2x because this side doesn't need to be fenced, only this side. So it's 2y, it's 500, 2y plus x. Okay, clear enough. So the second thing we need to do in an optimization problem is to isolate one of these, whatever, and put it into the other function. Let me show you how. In this case, we're gonna isolate x. So 2y is positive. It goes to the other side in a negative way. Let me show you how. It's x equals 500 minus 2y. That easy. Then we need to set up this formula into my other formula. So we know that x equals 500 minus 2y. And here we don't know how much is x. So we need to put area equals, instead of x, we're gonna put the value that we isolate. 500 minus 2y times y. The second thing we need to do the third thing we need to do on an optimization problem is to simplify. We can't simplify. If we can't, we need to eliminate terms. In this case, we can't. So, as your last resource, the thing that you need to do is to proceed. So, in case you can't simplify or eliminate any terms, you need to multiply. So, this is a binomial times a single term, so it's easy. So 500 times y, 500y minus 2y times y, 2y squared. Again, we need to simplify. We can't in this case, but if we could, we need to. So, as we can't, the fourth thing you need to do in an optimization problem is to how is this called? Derivate. we need to derive. So at the exponent rule, yes, as that rule tells us, if this is a 1, this goes multiplying, and this is minus 1. I'm gonna show you how. If we have a number and it's elevated to the square, to derive we need to drop the exponent and subtract 1 to the exponent. So in this case we drop the 2 and we subtract 1. So 2n, 2 minus 1 is 1, and every number to 1 we don't need to specify that, so it's only 2n. I wish I made myself clear. So to derive this we need to do a 500 because we dropped the exponent and we subtract 1, so y to the 0 is nothing, just 1, and 2 times 2, 4. y, 2 minus 1 is 1, so we don't need to specify that. Okay, we're done deriving. The fifth thing we need to do is again try to simplify or try to eliminate terms. If we can't, then we need to set up all the derivative equals to 0. I'm gonna show you how and why. So we need to set up equals to 0 so we can get y, and then we can solve our problem. So this is negative. To make our lives easier, we can pass it to the other side with a positive sign, so it's 4y equals 500. Then the 4 is multiplying the y, it goes dividing. Y equals 500 over 4. Okay, so as I said, 500 over 4 is 125. Okay, so then as we have our value in y, we can substitute in the original problem because we have our y. We can simplify even in this or in this. It's easier in here because you will have the pure value, not a formula. So 500, I'm gonna substitute this y in this formula, okay? 500 equals 2 times 125 minus, plus x. Okay, we're good. So 500 equals 150 plus x. We need to isolate x. So this, as it is positive, we can pass it to the other side in a negative way. So 500 minus 250 equals x. And then we just need to, do the subtraction. X equals 250. We have our two values. So we have this result, but we don't have the maximum. So the thing that we are gonna do right now is to evaluate in this formula. So the area is 250 times 125. So we're done. We just need to do the multiplication. And it's pretty easy. So here we are with an optimization problem. We are done, and I hope you enjoyed. I hope I get 100 because I really explained it very well. And thank you for watching, Jacob. I love you. Bye.